We're all live now.
Great. Thank you. Thanks everyone for joining us for this live stream ERMAC general meeting. It's our monthly meeting. And we have today a session on how to keep your AI and your organization out of jail. A very provocative topic, as AI brings our tremendous opportunities, but also has a dark side, machine bias. And so we're going to be talking about machine bias today. More businesses are using AI to support decision-making, and unchecked biases lead to biased products and services, which may discriminate against our customers or employees in ways that you are not even aware of. So today our speaker, and thank you for joining us, is Natalia Modjeska, a director, research advisor at Infotech Research Group, which is a Canadian-based organization and a think tank. She writes and speaks and advises IT organizations around the world on topics related to AI, machine learning, analytics, and governance. And she's currently developing an AI governance framework for Infotech members to ensure they build ethical, responsible, and trustworthy AI. At the end of this session, we'll be posting links for Infotech for getting more information on all of the topics today. Natalia has 15 years plus of experience in developing, selling, and implementing analytical solutions. Her diverse career spans from R&D and product management to sales, consulting, and program management. Prior to Infotech, she was an enterprise data and analytics program advisor at a global luxury hospitality brand. Natalia's journey into analytics and AI started in the 90s with a PhD in AI, focus on natural language processing, and at the University of Edinburgh in Scotland. And she also holds an executive MBA from the Ivey School of Business at the University of Western Ontario in London, Ontario. So thank you very much for joining us today. And we're all very excited to hear about your session today and your perspectives on AI and bias.
Thanks very much, Deborah, for such a warm welcome. I'm really pleased to be here.
Thank you. So if you could go ahead and share your screen and we'll get underway.
All right, let me do just that. All right. Okay, so before we dive into AI biases and how to keep our organizations out of jail, I'd like to mention that I will be using the words AI and machine learning phrases interchangeably. And the reason for it is because machine learning is really the foundation of technology that drives pretty much all of the current AI applications and makes them possible. And also, just because it's so foundational. Or as the joke goes, another variation of why, if it's written in Python, it's machine learning. If it's written in PowerPoint, it's AI. Very quickly about Infotech, highly relevant research to help IT leaders around the world to make strategic, timely, and well-informed decisions. And we have all kinds of, we cover all parts of the world and all levels of Canadian NASA among our members. And I focus specifically on artificial intelligence and machine learning part of the practice. Okay, that's enough about Infotech. So let me tell you a controversial truth that is not sort of something that a lot of people who do AI machine learning readily acknowledge, although they do know that. It's that it's also going to get worse because Like relational databases, AI is going to get into every important piece of software. That's a quote from Benedict Evans at his time at Andreessen Horowitz, a prominent VC firm, and that's from a couple of years ago. And guess what? It's not is going to, it's already happened. Interestingly enough, Pedro Domingos, a famous data scientist, said a few years ago before Benedict Evans, people worry that computers will get too smart and take over the world, but the real problem is that they are too stupid and they have already taken over the world. They actually have. Okay, and some of these systems actually make consequential decisions, and some of them harm people. And I will show you a few examples in a few minutes. But the challenge also with AI and machine learning, a lot of this is unintentional, the damage they cause, and you can't really see much of it and the bias until the problem becomes big and kind of, explodes like a volcano. It's not going to be a death by 1,000 cuts. It's going to be one big event that can really undermine your organization. And when it happens, it can negatively impact your organization's reputation or top and bottom line. And the way it could happen, the way it could play out is, well, firstly, if the systems you're using are biased, it can damage the trust that customers have towards the organization. They can sue you for discrimination. You may not have been able to identify some of your customer sort of slices or segments in the first place because of the biases in those AI machine learning systems, and in that case, it becomes a missed business opportunity. You can also become subject to regulatory sanctions, or maybe all of that can apply to your organization as well. And for some of you personally, if you're involved in making decisions around where to deploy AI and machine learning in your organizations, it could mean anything from not being able to sleep at night to, maybe in some worst cases, being walked out of the door. So, let's prevent that. Let's get educated on what this is, and hopefully, this is your presentation is going to help you to get that foundation. So, what is AI or algorithmic or machine bias? Well, Wikipedia defines it as systematic and repeatable errors in the computer system that create unfair outcomes, such as privileging one arbitrary group of users over others. And by the way, the key word here is, and I highlighted it, it's unfair. Okay, so here are a few examples. Apple Card is being investigated for gender discrimination complaints. And what happened when it was released very promptly last year is that a prominent software developer, David Heinemeier Hansen, I always have to look up his name, I'm sorry, but he's the creator of Ruby on Rails language. He was comparing his credit card limit with his wife. And it turns out he's got 20 times more credit than his wife. And some of you may be thinking, well, that's kind of makes sense. Well, it actually doesn't. Because lending organizations are not allowed to use gender as input variable in determining who gets a loan or credit or what have you. And because it's discrimination, it's against the law. And by the way, also in this case, this couple is married. They have the same assets. They've been married for a long time. They file joint tax returns and so forth. So the question is, like, what happened in this case? Why did she get less credit? Interestingly enough, just sometime later, just almost immediately after this became public, and by a very ironic and funny twist of fate, the same thing happened to Steve Wozniak and his wife. So he got 10 times more credit than his wife. Okay. Moving right along, this is an example from the healthcare industry. In the United States, many hospitals use commercial software, which decides who gets access to specialized care program. And this specific one decides who gets access to high-risk care management systems, so specialized nurses. And by providing these resources, obviously, the hospitals are able to prevent major serious complications. Later, they increase quality of care and patients' life and satisfaction and reduce costs down the road. And this particular system assigns lower risk scores to Black patients. So as a result, they receive less access to the specialized resources than the white patients. And I'm not going to tell you why it's happening yet, so bear with me for a few minutes, but we'll come back to this case because I also want to show you another recent one, and this is from the United Kingdom, and their sort of exam score generation algorithm got in hot water recently. It impacted an estimated about 40% of students, A-level students, which is high school students. And by downgrading their results, it effectively creates risk for many of the students not being able to get to universities of their choice. Luckily, the algorithm was rolled back, and the schools, decided to rely on teachers' input rather than the algorithm. Okay, so those were 3 examples of discriminatory systems, and I'm hoping it's clear by now that systems that make these types of biased decisions are discriminatory. And discrimination is clearly against the law. So I have listed here, for example, a few fundamental statutes in the United States. We have equivalent in Canada as well that prevent discrimination based on things like gender and disability and so forth. I also have a few more recent ones, and there are more coming out. And by the way, just because some of these statutes are kind of old and don't mention AI and machine learning, it doesn't mean that they don't apply, because we are going to see, we're already starting to see in some litigation, and we're going to see more. Now, I showed you a few examples of how a biased AI and machine learning system can harm your customers, consumers, citizens, stakeholders, employees, or partners. There are multiple other examples. For example, they can deny access to opportunities in life, such as education, financial services, housing, jobs, impact, obviously, access to healthcare. And there are also multiple examples where they led to, for example, incarceration, loss of liberty, and in some really bad cases, loss of life. So how does that happen? How do these biases, how do we end up with biased AI and machine learning systems? Okay, let's just peel the onion a little bit. When I talk about machine learning, and many of you are hopefully familiar with the process, it's a little bit like cooking. You need a chef or data scientist and maybe a data engineer to convert raw ingredients, in this case data, into a meal. And you obviously need also a recipe, which is your machine learning algorithm. And the dish itself, the outcome, is that machine learning model, which will be predicting future outcomes and help you make decisions. Now, just like with cooking, contamination, and think of bias as contamination, can be introduced into this process at any step. And once that happens, they propagate through it. Now, the majority also of biases come into the machine learning process and AI systems through the data, and that's why I highlighted them in red. Okay, and just to illustrate some of them for you, let's just start with this example from computer vision, where I'd like you to take a look at these 5 ribbons that represent images of cars from 5 different data sets or databases, which have been used to create machine learning models to help identify objects. Okay, I would like you to quickly scroll through them and think, which of these ribbons do you think represent a typical car? Okay, is it Pascal cars, Sun, Caltech, or something else? All right, and while you're thinking about that, let me then move to the next slide. By the way, interestingly enough, when I talk to a lot of IT audiences, they all go for race cars. So
So a
Despite the
question
best,
here,
yes.
Natalia. Isn't looking at a typical car also in the eyes of the beholder? So what I mean by a typical car might not be the same as what you mean by a typical car.
That's
Or
very
by
true.
country, perhaps.
That's
Different.
that's very true, right? And it's kind of a bit of a leading question. That's what I'm trying to tell you is these data sets have been put together by researchers who did their best effort to come up with very different images of cars, different cars that could, represent different images that represent cars. Okay, because with the machine learning model, we want to identify all kinds of cars. But if you look at these ribbons, what's interestingly, you can clearly start seeing biases because a lot of the images in the top ribbon show cars with non-canonical viewpoints, which means that the car shown from different angles, okay, and some weird angles, some of them. Then Caltech cars has a preference for cars or for images with side views, okay. As I mentioned, ImageNet is into race cars. And Sun cars and Label Me cars are very similar. They kind of have very diverse images, but the difference is in Label Me cars, lots of cars are occluded by small objects. So they include some sort of small object next to a car. So, I kind of asked the question a bit tongue-in-cheek because, again, the best efforts, despite the best efforts of their creators, these databases turn out to be biased, okay? And with bias is like with garbage in, garbage out. So if you unintentionally select these images using some sort of parameters, again subconsciously you will end up with biased images, biased collection, and as a result your system will be biased. Okay, another example or another type of bias is known as negative set bias. So typically in machine learning, we want to have a balanced data set on which we're going to train our algorithm and create the model. We need to have a good number of both positive and negative example. Because if we don't, if it's just too many positive example, the system will be unbiased. Okay, sorry, unbalanced. Okay, so this is known as negative set bias. Then there is a good question around data is, are there gaps in your data? An example I usually bring up is from Allegheny County in the States. They have created a system to help identify children who are at risk of maltreatment or abuse. Now, interestingly, a lot of their data, actually all of their data, comes from the county public data sources. They don't have access to private insurance data, for example, parents who are being treated for drug abuse or something else, or mental health issues. And as a result, when they build this model and the system to identify children who may be abused, well, they focus on the marginalized communities and people who are underprivileged, because these are the people who need access to county services and help. And so as a result, their data is biased and the system is biased, and they readily acknowledge that, but they still say that the system still helps us to save lives, and that's why they keep using it. Now, also, when it comes to machine learning, about 70% of machine learning system in use are supervised, which means that they learn from labeled examples. This is a car, this is a cat, a boat, whatever, a person. And so it becomes critically important to have accurate labels. So a question for you. Are these pictures or paintings? What about these? Are they pictures or paintings? And why does it matter? Well, it doesn't matter that much for us humans because we use those two words fairly interchangeably. We know kind of intuitively the difference. But for machines, they don't have no intelligence. There is no intelligence in artificial intelligence. It's all mathematics or statistics on steroids. And for them, because they learn from these labels, it becomes, again, it's critically important to have correct labels. So ask yourself if you're using your own data, if you've generated data yourself and label it yourself, or you're using, third-party services. There are huge factories and, farms, in, for example, in Asia and China that label images and video real time. Are they labeling it correctly? Because also keep in mind, there are biases that comes from us humans, and I'm going to talk about this in a few minutes. All right, change gears a little bit. Data itself can contain a lot of interesting surprises because many of these sensitive attributes, also known as protected attributes, such as gender, age, disability, and so forth, race, ethnic background, ethnicity, are redundantly or indirectly encoded in data. And what could happen, and you ask any data scientist, they will tell you that if they are present, you may inadvertently end up using them, even if you don't want to. And that's what I think happened in the case with the Apple card, because you can actually infer a person's gender from their shopping patterns. You can infer a person's age from their musical tastes. Zip codes can inform you of the person's race or income levels. And you can infer a person's gender from their family status. For example, if you're a financial services organization and if you ask an applicant's family status, well, 70% of single household are female households, it's a single mother, so you can infer the gender. A person's education, where they went to university, can tell you about their race. And height and weight will tell you the gender, because women are a bit lighter and shorter than men. And there are just multiple other correlation. Now, this is an example from social media. We've got a word cloud of representing, a language of females on the left and males on the right. And do you see any difference? I think you do. Men tend to use more stronger and more violent and sexual language. Now, why is this important? Because if you're using social media, if you're doing things like text analysis, sentiment analysis, we typically focus on negative sentiment, right? Because we want to improve our products, improve our services, make sure our customers, our citizens are happy. And as a result, you may be focusing on men because their language is a bit more negative than women. And as a result, you may end up discriminating against your female customers or citizens, okay? Now, I've given you a few examples of data biases. There are many, many more. But the question is, what can we do about them? Well, there are tools that could help you with identifying biases in your data sets that you use for machine learning, and I've listed a few of them. Basically, whatever vendor you're working with, IBM, Microsoft, Google, Amazon, they've got their own tool suites, including those to address bias and fairness. And there, I mentioned a few also here, academic ones and open source ones as well. But what I want you to take away from today's presentation, and I'm nowhere done, I'm just done with about a third of it, is that tools will only go you that far, because really, when it comes to biases, it's not a technical issue. The machine AI bias is really more of a social, political, and in the context of our organization, it's a business issue, which I hopefully convinced you by now about. And so we need to treat it accordingly. And we should use those tools to help with, fleshing out some of the data biases from the data. But we also should consider using frameworks like data sheets for data sets, which is really a new framework, which very quickly becoming a kind of leading established practice. It's based on the, what are they called? Typical, sorry, give me a second.
While you think, Natalia, we actually have an interesting comment in the comments that I thought you might just maybe have a thought on or something. Someone says, I thought this was an age of non-discrimination, but AI seems to work on biases. Like it specifically seems to focus on those.
Well, interestingly enough, what happens with AI is because AI and machine learning really relies on big data, and data encodes human behavior and a lot of social, cultural, historical, and societal injustices and biases. They all get reflected in the data, and they also get them magnified and systematized. And because then, this is the data we use to train our machine learning algorithms. And so as a result, they can get actually even amplified. And I think the whole scope and speed of AI adoption and automation is also contributing to kind of highlighting some of these biases that we may not have been, paying attention to. Hoping I answered the question.
Yeah, that's perfect. Thank you.
Okay. Now, this framework, data sheets for data sets, and the word I'm looking for is based on sort of model on electronic components that documentation comes in electronic components, usually lists, a lot of relevant information. And so the creators of this framework have actually taken the same approach to data. And what they ask you to do is go through a series of questions. I think they brought 40 to 60 questions, which helps you to think through and document how was the specific data set, which we are using for machine learning and AI, how was it created? Who it was created by, for what purpose, and so on and so forth. So highly recommend this one. I actually used it recently in one of my workshops. It's a little bit academic in nature, but you can easily take and adopt it to your organization and specific of your business. Okay, so we talked about data biases. So what can go wrong with our ingredients? Let's now also take a look at what can go wrong with the recipe. So,
sorry, Natalia. I think Deborah might have a question for you.
Yes, please.
Yeah. So back to the previous slide. That's a really interesting. Is this a product? Where do we find this framework?
I can send a link to this. It's actually, if you Google data sheets for dataset, it's an academic publication by researchers from Google Labs as well as Microsoft. It's a kind of it's a collaboration. So Google data sheets for datasets. It's available now on Archive.
Sure. So here's a question. Does it address the interactions of several data sets? Or do you have to combine them first and then look at the one data set against that criteria?
Well, interesting enough, what I was looking at Google, for example, and Google and Microsoft starting to use this framework to document some of their own data sets. And you can use it for one data set or you can do for multiple. So if you look at Google, for example, object recognition data set, I think one of the object recognition, I don't remember the second one, but they have created actual data sheets for those data sets. And for some of these projects or these tools, they use 3 data sets. So it covers both.
I see. So because I can't remember the citation right now, but somewhere I read, and I think this is almost a meme now, that if you have 21 pieces of data, you can re-identify individuals from anonymous data sets.
Absolutely. I recently learned from our security practice that, well, that was pre-COVID, but your flight patterns, like where do you fly to, when you leave, which airplane, which airline companies you fly with, are actually personally identifiable information, because on the basis of those patterns, you can infer an individual. And I was like, what? So it's not just, your name and biometrics data or your address and email address and what have you. It's actually also things like your, travel patterns are personally identifiable in a way. So I'm not surprised.
So getting probably reading ahead here into the recipe that you'll be getting into, combining data sets is a risk, because individually they may pass scrutiny, but once you combine them, you're getting into the 21 pieces of evidence to identify you and focus on you.
Absolutely. Yeah, it's a great one. Yeah. And as I mentioned earlier, there are these sensitive attributes that may be lurking or may be indirectly present in one of the data set, or maybe in all 3 or 4 or 5, how many you use, right? So you kind of need to be aware of that. Absolutely. And then interrogate all of them if you're planning to use them for your machine learning and AI project and experiments.
Thank you.
Yeah. Okay. All right. So shifting gears now back to what can go wrong with the recipe or the algorithm. Now, to really simplify kind of AI machine learning, I typically say it's really big data plus algorithms. And you can think of algorithms as an instructions recipe. So step-by-step instructions of what to do with the data. And interestingly, with machine learning is like with cooking eggs. It's the same data, but depending on which steps you apply and which sort of approach you choose, you made up with different recipes. And interesting enough, all these recipes on algorithms, they have their own inductive biases. An inductive bias is really a set of assumptions about the future, and that's actually what machine learning does, right? It finds patterns in historical data, and sort of you can use that to project future outcomes. To help you understand what inductive biases are, I usually use this example from Inductive Bias blog. It goes like this. If you've never seen a swan before and you see a black one, you will automatically assume that all swans are black. That's an inductive bias. That's how we humans learn. That's how we make projections about the future, kind of expect the future outcomes, okay? So that's an example of inductive bias. And it pretty much assumes that all swans are of the same color. Now, machine learning algorithms, they have inductive biases and they have individual ones. And I listed 3. And I don't want you to know the difference details, but they all kind of go through this black swan example and tell you what their biases are and what kind of they expect about the future. The reason I brought them up here is just I wanted to show you how very differently they approach this whole example with black swans. And by the way, if we were talking before the meeting about Facebook, for example, and Facebook algorithms, they have been designed to amplify and promote engagement. And it's a well-known fact. There are multiple examples of where Facebook algorithms have been biased, shown to be biased. So what I'm trying to say here, even by choosing a specific algorithm, you kind of choosing a specific inductive bias, and that's what gives it power. But it also could lead to some unintentional consequences. You remember this slide with the healthcare algorithm that kind of gives people risk scores that help them to assign specialized medical resources like specialized nurses, and in which case Black patients received lower risk score and had access to less resources than white patients. Well, why did it happen? Well, this is an example less of an algorithm bias. It's more an example of what's known as proxy bias. And it happened because we can't really predict, health needs. But we can look historically at health costs and use them as a proxy for health needs. If we spend more people, more resources on some people, they may be more, seriously ill. And that's what the creators of this algorithm assume. They use health costs as a proxy for health needs, and that's why it kind of backfired. Now, I have other examples of proxy variables and biases. And by the way, we use proxies in machine learning all the time, either for target variable, which is what we're talking about here. We also use proxy data sets because sometimes we don't have the data we need. And so, maybe there's something else that can stand in for the data we want but don't have access to. So examples I have here, how do we predict and choose universities where to send our children or go out, when we went ourselves? How do we select them? You can't really kind of quantify very easily things like the friendships you form during those times, the knowledge you gain. But things you can measure things like student-teacher ratios, acceptance rates, SAT scores, employment after graduation, how well alumni donate after they graduate. And if you can combine those, measurable results or measurable, what's to say, things you can measure, you can use them as proxy for educational excellence. And that's where university kind of rankings come in. That's what they measure. But again, what about those friendships? What about other things that we really enjoyed or maybe did not? I know somebody who went to Harvard, and the person says, that they would have been much better off and happy if they went to a smaller community kind of maybe college. How do we assess teacher effectiveness? And what makes a great teacher? Well, it's very hard to measure. So we looked instead at test scores of the students, of the pupils who take standardized tests. Okay, so we kind of also, what we do here effectively is we reduce a very complex situation, a problem, to something that we can measure. And we use lots of proxies in that case, okay? Or in the case of ProPublica's famous investigation into a sort of predictive policing or algorithm that was used to decide who could be released on bail and who stays in jail. Or predictive policing algorithms, they use a number of prior arrests to predict the likelihood of reoffense. But if you think about this, if we're looking at historical arrests, the only thing we can predict is whether the person is going to be arrested again. It's not the same as committing the crime, okay? Just slightly different things. That's like health costs and health needs are not the same thing. Okay, so the question becomes really, with some of these algorithms and model biases, are we really cooking the right dish? Okay. And there is another framework that I highly recommend. It's called Model Cards for Model Reporting. It's actually pretty much the same team who created data sheets for data sets. Then they realized, okay, we've come up with a list of questions to ask to interrogate biases in the data. Let's do something similar for those algorithms we choose and how we approach the whole design of the machine learning project. To be able to flesh out some of these design biases that I just, given you example of. Now, interestingly enough, also with some of these model and design biases, there's a bit of a correlation with likely, and I hate to use this word likely, but the more likely it is that we may have built a bias system. Because if you think about how machine learning works, it's really about optimization. It's really about getting the most accurate, performance, highest performance possible, because nobody wants to use a system which makes mistakes. So to do that, we will be squeezing all possible juice out of our data. And okay, so we talked about data biases. We talked about biases kind of on the model and design side of machine learning AI projects. Let's also talk look into what could go wrong with a chef cooking that machine learning dish. Well, Andrew Ng, who's a famous data scientist, chief data scientist at Baidu and co-founder of Google Brain, he says that applied machine learning is basically feature engineering. So 70–80% of machine learning is really doing things like cleansing data, partitioning, tuning, transforming, feature engineering, and so on and so forth. And it's really us humans who do all those things and make a lot of discretionary decisions about, how do we partition the data, how we transform it, and so on and so forth. And so it's perhaps not surprising that a lot of machine biases, AI biases, are a product of human cognitive biases. And that's kind of, the next few slides, which are really formulas. And they are an abbreviated way of doing something. So human biases have they're mental shortcuts. And if you look up the definition in Wikipedia, which I like doing, Wikipedia defines them as systematic deviations from rational judgment, which I laugh at, because what biases really are, the human cognitive biases are evolutionary mechanisms that help us to understand the world and make decisions very quickly. Now let me show you why and how. If you see this picture, do we trust her? Do we like her? And I think the answer will be yes. And you don't need to think about it. It's kind of like a split second. What about this? If you see something like this, you run, because if you don't, you'll be dinner. And when we lived in caves way back, many thousands of years ago, we kind of developed these evolutionary survival mechanisms, which are biases to help us, again, survive and make decisions very quickly. And we still carry them with us. They are, these individual cognitive biases or human cognitive biases are highly internalized. They are biological mechanisms hardwired in our brains. We use them all the time. We are not even aware of them. By the way, it also doesn't matter your educational level, ethnic background. Some of them are universal, some of them are culture specific, but we all have them. And if you're curious to test yourself, I highly recommend Project Implicit out of Harvard, which has several tests you can take to kind of figure out or assess yourself for identified. So if you think about that, we humans have all these built-in biases, it's perhaps not surprising, and we do build systems. It's perhaps not surprising that we end up instead with something more like opinions embedded in mathematics and not some rational, objective systems. That's a quote from Cathy O'Neill's book, Weapon of Math Destruction, which I highly recommend. Now, a lot of these biases also come from our cultural background, so the societal structures, and I don't have time to go through examples here, but also, and because of that, it becomes really important to have diverse teams to build these AI and machine learning systems. And currently, if you look at statistics, who is building AI and machine learning, it's not very encouraging, black people. And at Microsoft, at Facebook, they're only 4%. And the numbers may have changed, in the last year, but it's pretty discouraging. Or 80% of all AI data science sort of machine learning professors are AI machine learning systems within our organizations are as diverse as possible from the perspective of gender, ethnic background, disability as well, cultural background, and so forth. Now, more importantly, I also want you to think that it's really critical to ask questions. Again, you can use the tools, you can use the frameworks, just ask those questions, leave no stones unturned and no assumption unexamined. It's the only way to flash out and identify and then later mitigate these biases. Now, Assure available as a service to address the need, a common need across many industries, many organizations. What should you keep in mind? Well, AI as a service or machine learning as a service, just to extend that food analogy or cooking analogy, is like a DIY meal kit. You kind of buy your ingredients pre-chopped, pre-cooked, and then you kind of just cook them yourself, right? Or maybe just even heat it up in the oven, the microwave. But just because somebody pre-assembled ingredients for you or pre-trained that model, it does not, imply that they carry the risk and responsibility for that AI or machine learning product or service that you're building with their technology. And in fact, when it comes to some vendors, especially for those of you who will be working with new vendors, they are more riskier than some of the more established ones. Just because they may have a high ability to solve problems because they're more agile, they're smaller, they're more innovative, but they also tend to happen to have less money. They have much higher risk tolerance because they run fast and break things, and that's not what we want to do with systems that could potentially harm people. They also may have less diversity in teams and pay less attention to governance, and privacy may not be a cultural or economic priority for them. So if you're working with vendors, again, using a third-party AI or machine learning pre-trained models or a service, I recommend using this framework called fact sheets, and that's by, again, the consortium of researchers across IBM and other organizations. They created using as inspiration supplies declaration conformity, which accompanies many different products and services, which helps you to trace the product's lineage, performance characteristics, and so forth. So they basically done the same for AI, and it's a little bit more comprehensive than data sheets for data sets and model cuts for model reporting. It kind of combines those two, but plus additional questions that you can ask your vendor partner, and a good vendor partner should be able to provide you with that information. Now, another way to approach, a complementary way to approach AI biases within the context of your organization. What else do you need to have in mind and build and factor in? Well, I'd like to suggest four key principles. One of them is already mentioned. It's diversity by design and in design. So having diverse team and approach your AI machine learning projects and programs from a perspective of diversity. I also strongly encourage transparency. By transparency, I mean transparency with your customers, with your employees, with your consumers. We should be providing disclosure. How we've built the system, how is it operating, any biases that we have identified, and how we have mitigated them. Obviously not to open the kimono too wide and not disclosing any IP or proprietary information, but some basic information should be made available. And maybe going even further and collaborating with your customers in the design and building of the system and practicing the golden rule. Basically, let's treat our customers, consumers, citizens, partners as like we would like to be treated ourselves. A couple of other things is...
sorry to interrupt. One more question from the chat here. If biases can change AI in a non-biased direction, the powers behind must change. So who are the powers and who can influence this? Who are the powers behind it? Technology is only as good as human input. So like sorry, I'm just trying to... So I think the question is kind of about who is the powers that be that can affect these biases that are controlling these, like the suppliers and stuff like that, I guess.
All of us. And that's a very good question because we are all responsible for this. And I mean, as business leaders, as technical leaders, as implementers, as, maybe data scientists, data architects, solutions architects, we are either involved in building these systems or we are, authorizing and making decisions about the systems. So we are all responsible for them. Now, as consumers, I think we also are responsible in a way because we need to be informed. I mean, how many of us, as a result of GDPR, you go to a website and now you have this, you need to, what's the word, accept or decline their cookies and what have you. How many of us have actually gone to the settings? Sometimes you just get impatient and just like, whatever, I accept them without thinking, even if I probably shouldn't. But I think it's our responsibility as consumers to also ensure that, or at least ask the providers, is this system fair and non-discriminatory, and be aware of that and get educated. And also, if you come across cases where the system is discriminatory, it's unfair, it's biased, well, we should report them to relevant bodies or to investigative outlets like, for example, ProPublica or The Guardian, or there are multiple other ones. In fact, a lot of journalists, a lot of these cases of AI discrimination have been published and disclosed by journalists. So, we kind of need to take a stand here and make sure that we're all responsible, both from the business side as creators or users or deployers of the system, but also as consumers. We need to be aware and just be aware. Okay?
Absolutely.
I hope.
That's a great answer. There's also one other question, which is, are there any organizations or tools you can point to that provide a good example of good disclosure?
Yeah, well, it's kind of an emerging field, right? And so I recommend, again, looking up the big tech. So Google, for example, Microsoft, IBM. They have been part of developing these frameworks, the ones I mentioned. By the way, I just mentioned it's an emerging field. There's multiple other ones that the ones I selected is the one I kind of like, but the other ones. And they started to adopt them. And so for the data sets and the models that they provide to their vendor, so their customers, they actually started to populate these types of and provide these types of materials and documents. So if you go on their website, you should see some examples, or reach out to me, and I'm happy to share with you a few. Now, when it comes to mitigation, that's very much industry and organization specific, right? And it also ties to the question of how serious, how severe are those biases and risks that they bring. And there's also an interesting conversation there. Some of these biases give us competitive advantage. So yeah, it's a kind of more, I think, evolved conversation. Reach out to me if you want to talk more, okay?
Yeah.
But thank you
for the question.
One
more question from
yes,
chat,
please.
Because they seem to be really excited now. The last question is, privacy by design is used by many organizations to guide model development. Is there an overlap with these principles?
There is, and interestingly enough, there is a new, I guess, movement now happening right now. People talk about AI ethics by design. Okay, same sort of 7 principles that Anne Kabukian came up with for privacy. Now she also published 7 principles for around AI ethics. There are also multiple frameworks, standards, recommendations, best practices that are being either have been published or are being published around the world by different levels of government in Canada, United States, in Europe, in Singapore, I mean, everywhere, from UNESCO, United Nations, World Economic Forum, because everybody is, and academic as well, because everybody is, and sorry, big tech as well, because everybody is trying to increase public awareness of risks, but also kind of protects themselves. And I'm going to skip a few slides because I want to get this one, because really it doesn't matter what business you are in. We are all in the business of trust. Okay, and trust is something that you either have it or you don't. You can't give it out piecemeal, or you can't get it piecemeal. And for us as business organization or governments, when you lose that trust, it's gone. It's very hard to get back, and it's such a foundational prerequisite for the relationship we have with customers and citizens and consumers and partners as well, and employees. So that's why there's a lot of these frameworks happening. There's also a lot of regulation being put in place, from facial recognition technology ban in San Francisco and others. It's a very active area, and I compare it to the early 1900s, when we put cars, automobiles back then, on the roads. And if you look at old images, there were no signage, there were no traffic lights, there was no regulation. And then we realized that, okay, we need to come up with some sort of rules of engagement for each other, so we don't hurt people, and drivers don't hurt themselves. And so you can see that traffic lights started to pop up, and speed limits, and all other good things, and then the markups on the road. Because, and the same thing is right now happening with AI and machine learning. We kind of unleashed the technology, we started to implement it, and then we realized, oh, we need to put some guardrails and ethical guardrails around it, because it can actually, it's already harming people. Okay. All right, so I'm just thinking, going through. Another couple of things I want to mention to you guys, especially we're talking about ethics. As business leaders and technical leaders, in many cases, on the human benefits. What are we delivering to our consumers? What are we getting from them? What makes us unique? And maximize that mutual lifetime value So become less transactional and more relationship oriented, because if you focus on those business benefits or on the customer benefits, sort of adopt this customer centric approach to AI, then the business benefits will follow. And I usually bring up this quote from a local AI startup in Toronto. They build products that love people. And as much as I kind of find it a little bit cheesy, I still think that they are in the right direction. They think in the right direction. We should be focusing on the benefits we deliver to our customers with technology. And then again, all the business internal benefits will follow. Okay, so just to wrap it up, so how can we mitigate AI machine learning biases? Well, think about engaging a diverse design team. Use diverse data sets. Ensure that you have included all potential users and consumers in the design of your system. And not just users but consumers, but also maybe communities that can be impacted by that specific application. Use the golden rule. And then also treat bias as enterprise risk, because that's what it truly is. Again, it's not a technical issue, it's an enterprise risk. And more importantly, learn about technology, because knowledge is really power. So if you have any questions, you can reach me at nmojesk@infotech.com or on LinkedIn. Please connect with me. I'm happy to have follow-up conversations. I also have a few resources I highly recommend. There are a few books you can read. There are a few videos you can watch. The last one, the Scottish voice recognition elevator, is really hilarious 3-minute video that illustrates the dangers of biased speech recognition systems because they really impact even native language speakers who happen to have a strong regional accent, for example, in this case, Scots English. But, people with Indian, Pakistani background, Australians, women have trouble with some of these voice-activated systems. So anyway, just, watch this video, 3 minutes, and it's really fun. All right, that's all from me. Thanks again for your time. I guess if you have any time for questions, I'm happy to take it or do it offline.
I also want to chip in one thing to say Invisible Women is a fascinating book I got lent to me by a friend that just goes on and on about these things that I've never considered before, and each one is more fascinating than the next. Even like piano's design and stuff like that were touched on. It's great book. Some people are asking to please put your email back on because they missed it.
Here you go.
And another person has commented that
it's not really a talk, but I also have a more practical version of this our conversation as a workshop. And I think I mentioned I've really just done it with one of my clients in the States. It's a municipal government. And we go in sort of and look at the specific system, when they either build or planning to build, or maybe we deploy, and kind of interrogate it from different angles, data, algorithms, what have you, and look into identify the biases that could be lurking there. I think with this particular one, we identified 6 or 7, and then we build a mitigation plan around that. Mm-hmm. So yeah, and I gave the same presentation in 10 minutes, not the same one, but a condensed version. But yeah, anyway, reach out to me. What I'm trying to say, I'm happy to talk more about this. You've got my email address. You can find me on LinkedIn.
Right. Thank you, Natalia. I have one further question. What about bringing in consultants like social scientists who can actually dig into the potential societal biases or cultural biases, which, the IT team, even if they got great diversity, are still just IT people.
Absolutely. Yes, absolutely. Engage social scientists, engage ethicists, engage your customers, consumers, because sometimes, like this client I mentioned earlier, they made some assumptions about the people who would be maybe impacted by this, communities may be impacted by the system. And I said, well, why don't we go on and ask them, because it may not be again, we're making lots of assumptions, but that may not be the right ones because of our background. So yeah, engage as many people, as diverse people as possible. I can also mention to you that what's in addition to regulation, what's coming is perhaps certification for ethical, and rumors will not have the energy or the time to learn about AI and biases. But if there is a kind of certification mark of trust that the system, the application they're using are, responsible, fair, non-discriminate. And so there's a huge effort around the world, and I'm engaged in one of them with one of non-for-profit organization to create actually a certification program for ethical and responsible AI. We'll see how far it goes, but it's in progress.
Great. Well, thank you very much, Natalia. This has been a fascinating hour with you. We will be posting links, significant links against this video on YouTube for people's future reference. You can come back anytime and see this presentation again. I'd like to remind everyone that we are ERMAC, and we are everything data and information in the Toronto area, but we also have other affiliated chapters with us across Canada and through DAMA International, which represents data professionals around the world, over 80 chapters. If you're interested in us, please go and look at us at ermac.org for our programming and our offers to members, and even join ERMAC. This is the end of our session today, but please join us again in November. It will be the third Wednesday in November. Our sessions are always the third Wednesday in November, and that will be the 18th. So hope to see you then, and have a great evening. Bye for now.